In this tutorial, we'll set up some more complex car mechanics, including steering and drivetrain. Let's jump in. We'll use the Technic example car model that you can also find in the game. When we import the model, the four wheels are automatically configured, but as you can see, the steered wheels are rotating in place, not following the Technic steering mechanism, and the rear differential and pistons also aren't working. To set things up, we first disable the Simplified Wheels option. The auto-configured wheel setup remains effective. We select the front wheels and disable the Auto Animate option so that the wheel graphics doesn't follow roll and steering rotation automatically. We set this up in a different way. To animate the wheel roll in a way that also rotates the center axle and bush, we organize these pieces in a submodel in Bricklink Studio. We select that submodel here and add a rotation behavior. Select wheel roll as the input kind and select the wheel to use as the input. The rotation pivot point and axis is properly auto-detected. We can see that the rotation works right by pressing the up arrow. To animate steering, we select the submodel we created that contains all the parts that rotate together with steering input. Add a rotation behavior, the input is the steering value. We rotate the parts by 30 degrees, and for the pivot we select the holding lift arm, and adjust the pivot point coordinates and the rotation axis. Now we do the same for the other wheel. As you can see, the wheels themselves are now nicely steering according to the model mechanics. Car wheels are simulated with a special wheel collider in the game. These colliders are invisible during gameplay. By default, they are placed at the center of the configured element and they take the radius of the element. When we set up our alternative animation, the colliders aren't affected by default. This is intentional. As most Technic steering mechanisms don't keep the wheel steering rotation pivot point inside the wheels, they wouldn't drive in a stable way. You might have also noticed that we configured 30 degrees for the steering angle in the wheel behavior, and also 30 degrees for the steering animation. These values don't need to match, so you can have different steering parameters for the physical simulation than for the animation. Now let's animate the rest of the steering. For the steering rod, we add a translation behavior and set it up to follow the connecting pin. Then we select the vertical control axle. We can animate this in multiple ways, but the simplest now is to rotate this directly using the steering input. For the horizontal steering axle, we can also either use a gear-to-gear connection or directly use the steering input for the animation. Let's use a gear-to-gear connection now. We add a rotation behavior, set a part rotation as the input, select the input gear, and invert the factor to match the proper direction. The pivot was auto-detected. Now, you might have noticed that we were setting up the mechanism backwards, from the wheels up to the steering wheel. We could have also started from the steering wheel down to the actual wheels. As this is only an animation, it doesn't matter. You can use whichever way is easier in the current model. Although, in some steering mechanisms, the steering input is not symmetrical, so you need to turn the steering wheel by a smaller degree in one direction and a larger degree in the other direction. Starting from the steered wheels provides a more consistently looking animation in these cases. Remember that the actual steering used for the simulation is not affected by all this. Now let's see the drivetrain. We first disable auto animation in the rear wheels too. We set up rotation of the entire submodel containing both the wheel and the axles. For the differential itself, we created a submodel that contains the differentiating gear also. Here we won't animate the actual differentiating mechanism, we just take the rotation of either of the wheels. We could have also included the differential in the submodel with the axles on either side. Now we select the first connected gear and set up its rotation. We could also use the wheel roll directly as the input here, or use the differential frame as the input gear. Let's use the latter. The ratio is 28 gears to 20 gears, so 1.4. The top gear is submodeled together with the engine shaft. We take the rotation from the previous gear. To animate the pistons, we'll use hinge behaviors. We'll discuss hinges in more detail in an upcoming tutorial. Then we restrict the lateral motion of the pistons. And we're ready. This nice vehicle is now ready to play. In the next tutorial, we'll cover hinges, animating machines and environment interactions.